All right, so 9.5, the formulas that we have, there are two different types, horizontal and vertical. In a hyperbola, not hyperbole, the shapes will be going towards the outside. So a horizontal would mean that the foci and the vertices are horizontal with each other, so they're on the same y, they'll have the same y value. So they're on the x-axis, but they're going to have the same y value. And they're going to be pointing towards the outside, to the left and to the right. And then a vertical hyperbola means that they're going to be pointing up and down. So the actual graph itself are like it looks like two parabolas facing the outside, so they're facing away from each other. That's the actual graph. What we're going to do is find, like you see a rectangle, we're going to end up finding that and drawing that. And basically it's going to be like we had the major and minor axis in ellipses. It's kind of the same thing. We're going to be counting up and down our A value, left and right our B value. And then these dashed lines are called our asymptotes. So we will actually end up solving for our asymptotes by using this formula right here. But really it's just the point slope formula. So if you don't want to memorize this, it's the point slope formula, and you can just leave it like this as well. So it looks like a lot of things to memorize, but if you draw a picture, it makes it a lot easier. And then also in ellipses, c squared was a squared minus b squared. Now it is c squared equals a squared plus b squared. Yeah, it's just like the Pythagorean theorem. All right, so for number 1, we want to put it in standard form first. So when you look at standard form, what is it all equal to?
100.
In this equation, it's 100, but in the standard equation, it's equal to 1. So I need to divide everything by 100 first. And so that will make my equation y squared over what? 4 minus x squared over 25 equals 1. So you'll notice in this equation y squared is written first. And if y squared is written first, if you go back to the equations, does that mean that it's a horizontal or vertical type of hyperbola? Vertical. So if y squared is written first, that means that it is a vertical. And if it's a vertical, does that mean that it's going to be pointing up and down, or it's going to be pointing left and right?
Up and down.
Up and down. So my hyperbolas are going to be looking up and down. In the ellipses unit, the x or the a squared went under like the biggest term. So if it were horizontal, it went under the x. If it were vertical, it went under the y. In this lesson, the a squared always goes first and the b squared always goes second. So it doesn't matter if it's under x or y. A is always first and b is always second. Or a squared, I guess. So a squared and b squared, those never change. The only thing that changes is what goes in the top. So it's either y minus x or it's x minus y. If it's y minus x, then it's vertical, so it's going to be pointing up and down. If it's x minus y, then it's horizontal, and it's going to be pointing left and right. So my center, I look at the numerators, so x minus h, y minus k. It's like saying y minus 0 minus x minus 0. So my center would be where? At 0, 0. So my center is still hk. That would be 0, 0. Then I want to find the length of a, b, and c. So if a squared equals 4, then a equals 2. If b squared equals 25, b is 5. And then to find c, c squared equals a squared plus b squared. So c squared equals, I just add the denominators, 4 plus 25. So c squared equals 29. Or I'm just going to put c equals the square root of 29. And you simplify it if you can, but in this case, there's nothing that I can take out. So I'm going to leave it as the square root of 29. Don't put it into a decimal. Just leave it in its radical form. So what I do first, before I draw my hyperbola, is I draw the little dashed box that we saw on the last page, so with the formulas and everything. So I'm going to put my center at 0, 0. And then I'm going to go up 2 units for my A, down 2 units. So my A equals 2. I'm going to go up 2 and down 2 since it's a vertical. And then for my B, I'm going to go left 5 and right 5.
So do you always go up A?
No.
If it's vertical, you go up and down A, and then if it's horizontal, you go left, right A.
Okay.
Does that make sense?
Thanks for Thornhill.
So for my vertices, I'm going to name my ordered pairs of my A's. So what would my ordered pairs be when I went up 2 and down 2? What are those ordered pairs?
0, 2.
0, 2, 0, negative 2. Good.
Thanks, Maddie. Thank you.
She asked. So you
And it doesn't ask you for any co-vertices or anything like that. It doesn't ever have you label those. So the reason why we draw the B to the left and the right is so that we can make our box. So what you do is you just make a little dashed rectangle that connects the A's and the B's. Wasn't a very good rectangle. There we go. Trying to make it better. There we go. So it connects my A's and B's. Then to find my foci are always going to be on the same axis as your vertices. So it's going to be on that y-axis. It's going to be going up and down. So I start at my center at 0, 0. I'm going to add C, and then I'm going to subtract C. So I'm going to be adding it to the y value. So the square root of 29 is about like 5 point something, like around 5.5. So I just kind of guesstimate at negative 5.5, positive 5.5, and I draw my foci there.
Wait, how did you get that?
And they'll always be on the outside of your hyperbola. Well, they'll be on the inside of your hyperbolas, but it's like they're on the inside of each parabola. Does that kind of make sense? So when I draw, and I'm not going to make you have any exact values, when you draw, it's going to be something like this. And the reason why I made the slope look kind of like that is because imagine having asymptotes that go through the diagonals of your, that's kind of a curvy asymptote. Imagine having diagonals that go through your rectangle. So we're about to find the equation of those.
Wait,
so you could even draw your diagonals first and then make your hyperbola, or make your hyperbola after that.
Why do you draw those lines? What is the point of having the foci?
So the foci are basically they go with the slope of your hyperbola. So if your foci were closer into your rectangle, that would make you have a wider hyperbola, like it would be out wider. And then imagine taking those little dots, those foci, and like bringing them outwards. That would make it be skinnier. So foci in my mind are kind of like the puppet masters. Like they control how wide and how narrow your actual hyperbola is.
Like this.
Same with the parabola. The foci do that. And same with an ellipse. So imagine taking those and putting them on like a rubber band or a string, like stretching them out and making them skinnier. So then the foci, those ordered pairs would be at 0, and then I say 0 plus square root of 29, and 0, 0 minus square root of 29. So negative square root of 29. And I just leave it in the radical form.
Is C the distance between the foci and the center, or the distance between the foci and the...
foci in the center. So I always go from the center. Yes. And then the last thing is the equation of my asymptote. So what I do when I'm doing the equation of the asymptote is I take my box, I start from left to right. So I'm going to start in the bottom left-hand corner, and I'm going to go to the top right-hand corner, and I count the slope. So if I'm starting here, I go up how many? Actually, I'm going to start from the center. What I do is I start from the center, I go up 2, and I go over 1, 2, 3, 4, 5. So my slope would be 2 over 5. Then I take my center, so I'm going to put it in the point slope form. Does everyone remember the point slope form? Like y minus y, so I'm going to write it out to this side. Y minus y1.
Oh.
Or in this case, if you wanted to put h and k in it, because I'm going to use my center as the point every single time, you could say that it's y minus k equals, then you take your slope, and I think the equation is even on the front, like a over b or b over a. No, I'm not going to give you the equation, so you'll just have to find it. Then you take your slope, which would be 2/5, or in this case, it's a over b, and then x minus h.
Is it always A over B?
If it's a horizontal, then it's b over a. So that's why I don't say memorize the formulas, because it's easier for me to just visualize, like, what is this line right here to find the slope. So 2 over 5, x minus 0, and then over here would be y minus 0 equals 2 over 5 x minus 0. So you have a positive asymptote, and then you have a negative asymptote. So in front of the slope, you just put a plus or minus. So you'll have 2 equations. I will let you just leave the plus or minus in the front.
Where do you put the point slope?
In the front.
Can you put it in standard form?
Yeah, that's fine. You can leave it in point slope. You can put it in standard. I will accept any of it.
Do you want us to put it in front of the slope or in front of the whole problem?
In front of the slope. So my final answer for that would be y equals plus or minus 2 over 5 x. Because x minus 0 and y minus 0, it ends up simplifying. Plus or minus.
Oh my God.
If you want to split it up into 2 and put positive 2/5 x and negative 2/5 x, that's fine as well. Okay, so what I want you to do now is I want you to try number 2. Let's go ahead and decide if it's horizontal or vertical first. It's a horizontal because why?
X is first.
Because x is first, so it would be horizontal. And then I want you to fill in A, B, and C. My A is still first, and my B is still second. So for center, we got center where? -3, 2. So I'm going to plot my point at -3 up 2. It's my center. My A is what?
1,
B,
3.
3, because I take the square root of 9. And then C equals the square root of A squared plus B squared. So square root of 10. And so since it's a horizontal, that means I'm going to go left and right 1. And I know that because my A is under the X. So X means left, right, Y means up, down. So I'm going to go left 1, and I'm going to go right 1. And the ordered pairs of those would be my vertices, because vertices always go with A. And so my vertices are, what are the ordered pairs of those numbers?
-4, 2.
-4, 2, and -2, 2. Then I'm going to go up and down B. So I'm going to go up 3 and down 3. And I don't need to give the ordered pairs of those because we don't have covertices or anything like that. But I'm going to use it to make my rectangle. So I'm going to make my rectangle. And it looks kind of like a tall and skinny rectangle. Then you can draw your diagonal lines if you want. And I'm just going through that. Then I can draw from there. Once you have your diagonal lines, you can draw your hyperbola. So it's going to be kind of wide. And it always goes through your vertices. Like this. The next thing I need to do is find my foci. My foci go from the center. And are they going to be going left, right, or are they going to be going up, down? Left, right. They always go in the same direction as your vertices. So they're on the same line as your vertices. So foci are on same line as vertices. So I went horizontally for my vertices. I'm going to go horizontally for my foci. So I'm going to start at -3, 2. And I'm going to go left square root of 10. And I'm going to go right square root of 10. So my x always, or my y always stays 2. But I'm going to take my x, -3, and I'm going to subtract square root of 10, comma 2. And then my second ordered pair would be -3 plus square root of 10, comma 2. And you just leave it like that. Leave it in the radical form.
So it always starts off as like your center, right?
Uh-huh. It always starts off as your center. I subtract square root of 10, and I add square root of 10. The square root of 10 is like 3.2-ish. So I'm just going to go about 3 to the left and about 3 to the right. And just put my dots. And I'm not going to be picky about that. But remember that your dots will always go outside of the hyperbola, but like within those two parabolas. Because essentially that's what a hyperbola is. Then I'm going to do the equation of my asymptote. So I'm going to start at my center, right here, at -3, 2. And rise over run, my slope would be what? If I start at -3, 2, I go up how many? Up 3 over, so plus or minus 3 over 1. X minus h plus k. So x plus 3.
So it's B over A now?
Yes, because it's a horizontal.
Oh.
So if you don't want to memorize that it's A over B and B over A, I always start from my center. I go up 3 over 1. So how do I get from the center to my top right-hand corner? You go up 3 and you go over 1. X minus 3 plus K, so plus 2. That would be my final answer. And you don't have to FOIL it out or distribute it and then find any of that. So I'm just basically finding what the equation of the line is for my two orange lines. So it gives me vertices and then it also gives me foci. So one thing that you could do is you could graph it. And that's usually what I suggest to do because it's hard for me to visualize if I don't have a picture. So I'm going to kind of just draw one out to the side. It says vertices at 1, 3 and -5, 3. And then if foci are at 3, 3 and -7, 3. So 3, 3 and -7, 3. So what type of hyperbola would this be?
Horizontal.
Horizontal, so that means that it's going to be looking something like this. Because my foci are on the same y-axis, so that means it's going to be horizontal. If it's horizontal, then what is the equation? I'm just going to write the general equation.
It's gonna be X plus something or whatever.
X minus h
X minus.
squared over a squared minus y minus k squared over b squared equals 1.
Wait, how did you know it was horizontal?
Because when I drew my picture, everything was on the same y-axis. So if my foci and my vertices are on the same y-axis, it's horizontal. And if they were on the same axis, then they would be up and down, which would mean that it's vertical. So this in this case, it's horizontal. So that's why I say draw a picture, because it really does help. So I need to find my H, my K, my A, and my B. And so the first thing that I need is my center point. So the midpoint between my vertices, I can either do the formula or I can just look at it. So what is the distance, or what would be the center point from my two vertices?
-2, 3.
It would be -2, 3. So my midpoint, which would also be my center, would be -2, 3. You can just look at it or you can do the midpoint formula. Then I need A and I need B. A is the distance from my center to my vertex, or to my vertice, so that would be 1, 2, 3. So A equals 3. I also have my foci, so the distance from my center to my foci is what letter? C. So the distance from center to foci is how many? 1, 2, 3, 4, 5. So C equals 5.
No, B equals 2.
No. So C squared equals A squared plus B squared. So C squared is 25 equals A squared, which would be 9 plus B squared. So B squared equals what? 16. So B equals 4. But I really only need B squared because I'm plugging it right back into B squared. So you could say B is 4, but you don't really need that. You just need B squared. So I'm going to plug everything in. It would be x minus h, so x plus 2 squared over a squared, which is 9, minus y minus k squared over b squared, which is 16, equals 1. And that would be my final answer. Okay, so last one, it's giving you a graph and it's saying find the equation. So first off, is this horizontal or vertical?
It's
Horizontal, so the equation is what? X minus h squared over a squared minus y minus k squared over b squared equals 1. So then I need to find my center, which would be hk, the distance from center to vertice, which would be a, and then b, I'm going to have to solve by getting c and then doing c squared equals a squared plus b squared. So first thing is center. Just by looking at the equation, can we just eyeball it and see what it is? We know that the y-axis is going to be 1.
3, 1.
-3, 1.
-3, 0.
Well, it's 5, 1.
So -3, 1. You can do the midpoint by using these 2 points right here.
What stinks is like little dots on the actual line. So that
I know, so it tells you where the x-axis, or it tells you where the x-intercepts are, which is unfortunate. Okay, so I'm just drawing in my vertices. So I just drew in my vertices, and now I need to find the distance from center to my vertice, which is how many units? 2. So A equals 2. Then I'm going to find the distance from my center to one of my foci. So 1, 2, 3, 4. So C equals 4. So A equals 2. C equals 4. So B equals...
Is that a 2 or a 3?
2.
-2, 1.
Oh, this right here is -3, 1. I just didn't erase it.
Wait, so isn't it supposed to be the vertices average?
No, it's just the distance from center to vertice
Isn't that
is your A. Yeah, it could also be the distance and then in half. That's fine. It's easier to just count though.
Square root of 12.
So then to find my b, c squared equals a squared plus b squared. So 16 equals 4 plus b squared. So b squared equals 12, or b equals the square root of 12. But really all you need is your b squared. So I have all that I need. I have my center, I have my a, and I have my b squared. So my final answer, since it's horizontal, would be x plus 3 squared over 4 minus y minus 1 squared over 12 equals 1. And then the last two are completing the square, which I feel confident in because we've done that before.
Yeah, well done.